guys, my name is Craig and welcome to Peri Solutions. Today we're going to look at how we differentiate implicit functions. So for all the differentiation that we've covered so far, we could express our equations in the form of y is equal to f of x. But there are situations whereby y cannot be expressed explicitly as a function of x. So in that form, we've got what we call an implicit function. For example, if we look at this equation in blue, it says x squared minus y squared plus y is equal to 1. So as we can see here, it is very difficult to express y in terms of x. So this is what we call an implicit function. Now I would like to look at how we differentiate implicit functions. So now let's take this first example. We want to find the gradient function of y to the power of 3. So we are saying d by dx of y to the power of 3. So we are differentiating y, but this is with respect to x. So what we do is that y to the power of 3. So what we do is that we differentiate y to the power of 3 the normal way that we would differentiate x to the power of 3. So we know we drop the power, multiply by 3, then subtract 1 from the power. Right. So drop the power, multiply by the y, then subtract 1 from the power. And then after this, we multiply this by the expression of dy by dx. So the final result of differentiating y to the power of 3 with respect to x will be given as 3y squared dy by dx. So this is how we differentiate this, the first one. Now I would like to look at how we differentiate the second one. We want to find the gradient function of the expression y squared times y to the power of 3. So allow me to erase this part. So for the second part, we want to find d by dx of x squared times y to the power of 3. But what do we know about x squared y to the power of 3? This is a product. And from the previous modules, we talked about how we can use the product rule to differentiate a product. So we shall let y squared, x squared be u, and then y to the power of 3 be v, such that this would be equal to u dv by dx plus v du by dx. So now our u would be x squared, then times dv by dx. We want to differentiate y to the power of 3 with respect to x. So first of all, we say we differentiate this y to the power of 3 the normal way, whereby we shall drop the power, multiply by y, then subtract 1 from the power. And then after this, we multiply by the expression dy by dx. Then we're going to say plus v, our v is y to the power of 3, times du by dx. So now we want to differentiate x squared with respect to x. We just drop the power 2, then multiply by x, and then subtract 1 from the power of 2 to get a power of 1. So now we shall simplify this, whereby we're going to get 3x squared y squared dy by dx plus 2x y to the power of 3. Okay, so this is what we get for the gradient function of the expression x squared y to the power of 3. Now I would like to look at this example number 3. Allow me to erase this part. Okay, so for this number 3, what we want to do, we want to find the equation of the tangent to this curve at the point 1 over 3. So as you can see, this curve says that 2x squared plus 3y squared minus 3x plus 2y is equal to 0. So we want to find the tangent, equation of the tangent to this curve at that point. So first step, we know that this is now number 3. So first step, we know that we find our gradient function, which is dy by dx. So to find our dy by dx, we shall write this equation in full as it is. So it says 2x squared plus 3y squared minus 3x plus 2y is equal to 0. So finding the gradient function, we shall differentiate each term separately. So we are saying that d by dx of 2x squared plus d by dx of 3y squared minus, let's say plus d by dx of minus 3x, then plus d by dx of 2y. This should be equal to d by dx of 0, which is just 0, like that. So now we shall differentiate these terms separately. D by dx of 2x squared, we know that we are saying that we are dropping the power 2, that is multiplying by that 2 to get a 4, then multiplying by x, then we subtract 1 from the power of 2 to get a 1. So after we differentiate 2x squared, we get 4x, then plus. Now we want to differentiate 3y squared, but this is with respect to x. So we say we first of all just differentiate this 3y squared the normal way, whereby we're dropping the power 2, that will multiply by that 3 to get a 6. Then we multiply by y and subtract 1 from the power of 2 to get a power of 1. And then we multiply this by the expression dy by dx. Like that. So this is what we get when you differentiate that. And then now we would like to differentiate minus 3x with respect to x. We know that we just get a minus 3 there, because x to the power of 1, dropping the power 1, multiplying by minus 3, then subtracting 1 from the power of 1, we get x to the power of 0, which will just give us a 1. So now let's differentiate 2y with respect to x. We just get a plus 2 after we differentiate 2y the normal way. But remember, this is with respect to x. So we then multiply by the expression dy by dx. And then you equate that to, equate it to 0. So now next step, because isn't it we want the gradient function, so we shall now make dy by dx subject of the formula. So we know if we group like terms, we've got 6y plus 2, allow me to write it here. So from here we've got 6y plus 2 times dy by dx, right? I've just combined these two, right? These two, and then I affected out the dy by dx. And then now if we take 4x minus 3 to the other side, it becomes 3 minus 4x. Like that, correct? Yes. So now to find dy by dx, we shall divide both sides by 6y plus 2. dy by dx will be 3 minus 4x over 6y plus 2. So now this is the gradient function of that curve. Now the next step shall be to find the actual gradient after we substitute these two, the x coordinate and the y coordinate. So we are now saying when x is 1 and y is 1 paired, what is the dy by dx? So this will be 3 minus 4 times 1, which is 4, over 6 times a paired, we get a 2 plus 2. This will simplify to minus 1 over 4. So minus 1 over 4 is the gradient of this curve, which is the same gradient of the tangent at that point. So now to find the equation of the tangent, we shall simply use simple y is equal to mx plus c, whereby we're saying y minus y naught y naught 1 should be equal to m x minus x naught 1. So now if we say y minus y naught 1, that's 1 over 3, is equal to m, which is minus 1 over 4, times x minus 1, like that. And then multiply both sides, multiply throughout by 12, we shall get 12y minus 1, minus 4 here, equals times 1 over 3 times 12, we get a 4, should be equal to minus 3x plus 3. So we can take the minus 3x that side and then the minus 4 that side to get 12y plus 3x is equal to 7. So now this would be the equation of the tangent at this specific point to that curve. Okay, so this was looking at differentiating implicit functions. Please don't forget to leave a comment, drop a like, and share. And if you're new to my channel, make sure you subscribe. Thank you.